So, we are discussing about the L'Hopital rule when x goes to x naught. Now, here we can also consider x naught to be infinity. So, this is the theorem which we can derive it easily from the L'Hopital rule, that if let f and g, this is from a to infinity for some a, are differentiable given to us, and g prime of x, this is not equal to 0 for all x belongs to m infinity for some m positive. That means outside, that is what the x goes to infinity means, limit. So, if f limit x goes to infinity f prime of x by g prime of x, this is equal to L, then limit x goes to infinity f of x by g of x, this is also going to be equal to L. So, the proof, if we can take that f of t is equal to, define is equal to f of 1 over t, and g is if t is not equal to 0, and 0 if t is equal to 0. Okay, so, let us for the time being, and if you define g of t, this is equal to small g of 1 over t, if t not equal to 0. Now, definitely f and g, they are function from 0 to 1 by a to r, differentiable functions, and f prime of t, this is equal to f prime by chain rule 1 by t into 1 by t square, and g prime of t similarly is equal to g prime of 1 over t into 1 by t square. Now, f prime t by g prime of t is equal to f prime of 1 over t divided by g prime of 1 over t, because 1 over t square will get cancelled. This is negative of this. So, limit t goes to 0 plus f prime of t by g prime of t, which is equal to f prime of x is equal to L. Now, we can apply the version. For that, what we need to get is that as limit t goes to 0, f of t has to be 0 and g of t has to be 0. That means, this is what we are going to get, that limit t goes to 0, capital F of t 0, then this is f. Now, if limit x goes to infinity f of x, this is equal to infinity, and limit x goes to infinity g of x is equal to infinity, then what we get that when t goes to. So, if we have the condition limit t goes to 0 f of t, this is equal to 0, and limit t goes to 0 plus g of, which is equal to g of t, then we are done. That means, essentially what we need to impose this condition is that limit f of t, t goes to infinity, this is equal to 0, which is equal to limit t goes to infinity of g of t. Then you can apply the earlier L'Hopital rule. So, what you are going to get is that even for the t goes to infinity. So, Similarly, we can prove for x goes to negative infinity. Now, for the application, let us see find other indeterminate form in which we would like to get uh, limit by using L'Hopital rule. So, let us look at this famous limit which is very important, 1 by x. Now, this is 1 plus x goes to 1 as x goes to 0 and 1 by x goes to infinity as x goes to 0. So, this is 1 by 1 to the power infinity form. This is again indeterminate, because this we do not know what it is. This cannot be determined 1 to the power infinity. So, how we are going to find the limit? Now, let us write 1 plus x to the power 1 over x cleverly as e to the power ln 1 plus x to the power 1 over x by the logarithm rule. This is going to happen. So, this is equal to e to the power ln 1 plus x divided by x. Now, e to the power x is a continuous function, therefore, limit x goes to 0, 1 plus x 1 over x, this is equal to e to the power limit x goes to 0 ln 1 plus x divided by x. This we have computed earlier. This is going to be e to the power 1, which is equal to e. So, this is another definition of e, what we are going to get through the limit. And also look at, this is one, let us look at another example. Limit x goes to infinity x sin 1 over x. This is of the form infinity into 0 form. So, now how we are going to find this? This is we can put it sin 1 by x divided by 1 by x. Now, this becomes 0 by 0 form. So, 0 by 0 form we have done the limit as x goes to infinity. So, this is precisely equal to limit, I can change that, y goes to 0 sin y by y, which is equal to 1. So, now we can also have limit x goes to infinity, let us say ln x by x. This is of the form infinity by infinity form. So, now what one can do is that essentially I can write that 1 over f this. So, which is equal to 0. Another example you can see, let us say limit x goes to 0 x to the power x. Now, this is 0 to the power 0 form, 0 to the power 0 is not determined, because anything any power to the 0 is 0 and any number to the power 0 is 1. So, we can't determine this. So, now how to do this? So, this is exactly what we did it for x plus 1 to the power 1 by x. So, this is, I can write this as x ln x, which is equal to limit x tends to 0 e to the power ln x divided by 1 by x. So, this is equal to e to the power, this is of the form infinity by infinity form, and we have is 1 over x divided by minus 1 over x square. So, this is going to be equal to limit x goes to 0 e to the power minus of x, which is equal to 1. Another example, let us take limit x goes to infinity x to the power 1 over x. Again limit x, this is infinity to the power 0 form, x goes to infinity e to the power ln x by x. Now, this we have found out earlier that limit x goes to infinity ln x by x is nothing but 0. So, this is limit e to the power rather 0, which is equal to 1. Okay. So, one remark I would like to make is that it is not true that L'Hopital rule is going to address all 0 by 0 form and will give us a limit. Let us look for this example. We are interested, let us say x goes to 0 e to the power minus 1 over x by x. Now, this is 0 by 0 form. So, now if I want to apply repeatedly, now if I take f prime of x, then this is going to be e to the power minus of 1 by x into minus 1 by x square into negative 1 plus, and g prime of x is equal to 1. Now, limit x goes to 0 f prime of x by g prime of x, this is equal to limit x goes to 0 e to the power minus of 1 by x divided by x square. Now, we would like to find this. Now, for this f is e to the power minus 1 by x and g is x square. So, for again by if I want to look at f double prime of x by g double prime of x, this is going to be e to the power minus 1 by x by 2 x cube. So, if I go on like this, then f n of x by g of n of x, this is equal to e to the power minus of 1 by x n factorial x to the power n. So, our life is not becoming simple by doing this. So, one need to check that whether f prime of x by g prime of x limit, this must exist, then it is easier. So, with in some cases what happens is that you can do it repeatedly for 2 or 3 times, but every time you need to check that whatever the function you are choosing, then f and g, in order to apply L'Hopital, what you need to do is that you need to check that the limit of f prime by g prime that exists, then only L'Hopital is going to work. So, now let us come to the proof of the L'Hopital rule. So, what does it say? Now, suppose if I define a f of x, let us say f of x, x not equal to a and 0 if x is equal to a, and g of x, this is equal to g of x and 0 x not equal to a and x is equal to a. So, obviously, as we have seen in the first proof of the L'Hopital, f prime of x naught by g prime of x naught, this is equal to f of x minus of f of x naught, because f of x naught is 0, g of x minus of g of x naught. So, this is f x by g x. So, here what we are going to get is that something like, if intuitively what we want to get is that f of x minus of f of x naught, which is again equal to 0, by g of x minus of g of x naught, this is equal to now capital F. So, this is nothing but f of x by g of x. Now, mean value theorem says that if we have f of x minus of f of x naught, this is equal to f prime of some c naught, some c, c1 let us say, x minus of x naught, and g of x minus of g of x naught, this is equal to g prime of c2, x minus of x naught. So, now this ratio, this is going to be f prime of c1 by f g prime of c2. The life would be easy if we get that in the mean value theorem f of x minus of f of x naught divided by g of x minus of g of x naught, this is equal to f prime of c by g prime of c with one uniform c. So, that is what is our next important theorem to. So, this is just the rough work for you. Now, I will write down the Cauchy mean value theorem. Let f and g from a b to r be continuous. And both f g differentiable on open interval a b. Now, suppose g prime of x is not equal to 0 for all x belongs to a b, then there exists a c belongs to open interval a b such that f of b minus of f of a divided by g of b minus of g of a, this is equal to f prime of c by g prime of c. You see, this is important is that f of b minus of f of a, f satisfies mean value theorem condition, g also satisfies mean value condition. So, now numerator will be f prime of c 1 and denominator will be g prime of c 2. So, that is very easy, but now what is important of this theorem is that you are getting one c for the ratio. Okay. So, now what you want actually in this case, that you would like to get f, suppose if f of a is equal to 0, then you will get f of b by g of b is equal to f prime c by g prime c. That is what you would like to get. So, which means essentially you are looking at the ratio f x by g x, right. So, now define capital of f of x, this is equal to f of x minus of f of a minus f b minus f a divided by g b minus of g a into g x minus g a. Now, this f is differentiable, g is differentiable, rest of them are scalars. So, capital F is differentiable, f is continuous on a b and f differentiable on open interval a b. And what is the derivative? F prime of x, this is equal to f prime of x, f of a is 0 minus f b minus of f a divided by g b minus of g of a into g prime of x. So, I can find a c such that if capital F prime of c is equal to 0, then I am done. Now, how to find a c such that f capital F prime of c is going to be equal to 0? Now, look at f of a, which is equal to f a minus f a is 0 and g a minus g a is 0. So, this is 0. Now, look at f of b. F of b is f b minus f a minus f b minus f a by g b minus g a into g b minus g a, this gets cancelled. So, what you are going to get that this is also equal to 0. So, by Rolle's theorem, what we have is that there exists a C belongs to A B such that f prime of C this is equal to 0. Now, f prime of C is equal to 0. So, then this will imply that f prime of C is equal to f of B minus of f of A divided by g B minus of g of A into g prime of C. Because g prime of C is not 0 anywhere, so we can divide it by g prime of C. So, what we get is that f prime of C by g prime of C is equal to f b minus f a by g b minus g a. We will apply this to prove the L'Hopital, and but before that there will be a very interesting inequality. I mean, one would like to see that so that for x greater than 0, we will actually see that what is the relationship of cos x with 1 minus x square by 2, rather I would like to put it 1 by x square by 2 factorial. So, now let us take f of x, this is equal to 1 minus cos x, and g of x, this is equal to x square by 2. Now, both are continuous and differentiable function, and therefore, what I get is that and f of 0 is equal to 0 and g of 0 is equal to 0. So, f of x minus of f of 0 divided by g of x minus g of 0, this is equal to f prime of c by g prime of c by Cauchy mean value theorem. Now, this is implied that f of x is 1 minus cos x, f of 0 is 0, g of x is x square by 2, this is equal to sin c by c. Now, this is less than 1. So, therefore, 1 minus cos x is less than x square by 2, hence 1 minus x square by 2 is less than cos x. Okay, so, now let us try to get the proof of this L'Hopital rule. I will just give you the sketch of the proof. So, what it is saying that if f of x naught is equal to g of x naught is 0 and g prime of x naught is not equal to 0 on the deleted neighborhood of x naught, and the limit of the ratio of the derivative if it exists, then we know that limit x goes to x naught, same limit. Okay. So, now to prove this, now define capital F of x, this is equal to f of x if x not equal to a and 0 if x is equal to a, and g of x similarly we will just define g of x, x not equal to a, 0 if x is equal to a. Now, let us take then f and both g. Now, they are continuous function from closed interval a b to r, continuous, and differentiable on a and x. Let me take a is less than x is less than b. Therefore, by Cauchy mean value theorem, what I am going to get is that f of capital F minus of f a, this divided by g of x minus of g of a, this is equal to f prime of c by g prime of c for some c belongs to a x, some c belongs to a and x. Okay. So, this will imply that this is a f of a is 0. So, this is f of x times g prime of c, this is equal to g of x into f prime of c. Now, g prime of c is not equal to 0 given, actually it is given to us that g prime is never 0 on the deleted neighborhood of this. So, now if we know that g of a is equal to 0, now if g of x is equal to 0 for some x, then capital G of x is also equal to 0. Now, here is a, here is x, g is a differentiable function on open interval a x and is continuous, g of a equal to 0 equal to g of x. Therefore, there exists a c naught such that g prime of c naught, this is equal to 0. This implies that g prime of that c naught is equal to 0, that because this c naught is lying between a and x. So, obviously, what we are getting, this g of x is not equal to 0. Therefore, we can divide it. So, f of x by g of x, this is equal to f prime of c divided by g prime of c, and the c is where? C is lying close to, when I come, if we take, if x goes to a, then this will imply that c will also goes to a. So, this imply limit of x goes to a, f of x by g of x, this is equal to limit x goes to a, f prime of x by g prime of x. This is what is the sketch of the proof of the L'Hopital real. So, we will stop here, and in the next class we will see some more application of differential calculus. Thank you.